So we just learned the power rule, and the power rule is fantastic. Like it allows us to take derivatives really quickly. Unfortunately, as you just learned, it can only be used for things like this. I mean, like, we can do things like this, but only because we can rewrite them as x to the negative 1/2. Right? We can deal with things like 1 over x cubed, but only because we can write them as x to the negative 3rd power. If you have anything that can't be written as just this, as just x to a power, like we are currently out of luck. We have to use the long method, which you guys probably weren't a huge fan of. Right? So in this lesson, I'm going to sort of expand what we can take the derivative of. We're going to learn some properties of differentiation that will allow us to take derivatives of slightly more complicated things. There are going to be 3 properties we're going to learn, so here they are. The first property I'm going to call the constant rule. Right? And in mathematics, the constant rule simply states this, that the derivative of c, where c is a constant, is 0. Right? In English, I'm expressing this down below. The derivative of a constant is always 0. So if you're doing a problem and at some point somebody asks you, hey, what's the derivative of 15? The answer is 0. Right? If we ask, what's the derivative of 31? It's 0. The derivative of negative 15, 0. The derivative of pi, 0. The derivative of any constant is 0. Okay? I don't think I can resist telling you why. I'm sorry, I have to do it. Remember what the derivative is supposed to represent. The derivative is supposed to represent the slope of the tangent line. Think for a minute about what this function looks like. That's a constant function, right? It's the function 5, right? The graph of 5 looks like this. 5. There's the 5 function. What's the slope of the tangent line to that function everywhere? Like, think of it. If you picked any point on this line, the tangent line will be horizontal. It will be a 0-sloped line. It makes sense that a constant function, which will always be represented by a horizontal line, will always everywhere have a slope of 0. Like, this actually makes sense. Like, we need to memorize it. The derivative of a constant is 0, but it also makes sense. The next rule is called the constant multiple rule, and this one's actually really helpful. What this one says in mathematics is, if someone asks you to take the derivative of c times f of x, so some constant times f of x, that's the same as taking the derivative of the function and multiplying by the constant. Right? And I think I more or less just said that in English, right? When you take the derivative of a function multiplied by a constant, you can take the derivative of the function, then just multiply by the constant to the end. So this example I have below, where I say, hey, if g of x is negative 7x squared, what is the derivative of that thing? Somebody might say, oh, we can't really take the derivative of that thing, because it's not really the power rule. There's a 7 in front. That's true, but that 7 is a constant, and that's very important. Because that 7 is a constant, what we can do when we take the derivative is we can set the negative 7 aside, and then just think to ourselves, okay, what is the derivative of the x squared part? And this should be very easy. You guys should be able to pause the video and think about this. To take the derivative of that, I'm going to bring the 2 down, write the x, and then I'll subtract 1 from the power. So 2 minus 1 is 1. Great. The derivative of x squared is 2x to the first, so 2x. So that means the derivative of g will be negative 7 times that, so it'll end up being negative 14x. That is my derivative. And so you can see how the constant multiple rule greatly expands what we can do. Right? Now, not only can I do x raised to any power, but if it's multiplied by a constant, huge point, if it's multiplied by a constant, we can take the derivative. We just set the constant aside, do the derivative, and then multiply it back in. The last rule I'm going to cover in this video, the last property, is called the addition-subtraction rule, or the addition-subtraction property. And, we have both the mathematics and the English here. Try and read this mathematics. It says if you take the derivative of a function plus or minus another function, that'll be the same as just doing the derivative of the first function, plus or minus, the derivative of the second function. So it just means if you have 2 functions added together, or 3 functions added together, or 17 functions added or subtracted together, you can just take the derivative of each individual piece and then add or subtract them together. Right? So this example I have down below, right, I'm giving you the function h of x equals 5x squared minus 13x plus 7,053, and I want you to find the derivative. We should be able to use the addition-subtraction rule, the the constant multiple rule, the constant rule, we should be able to use all 4 of our rules and the power rule to figure out what this derivative is going to be. So pause the video, try this derivative on your own, and see if you can come up with that. So the first thing we notice is there are 3 terms here that are separated. So I can do each of those derivative pieces individually and just connect them with a subtraction and with an addition. Right? So when I do this problem, my h prime of x, first I'm going to tackle the derivative of the 5x squared. Right, so how am I going to do that? Well, I'm going to set the 5 aside, and then I'll multiply by the derivative of the x squared. The derivative of x squared is 2x to the first power, so great, it's 2x. Right? Then I'll have my next thing, this minus 13x. So I have minus 13 times the derivative of the x part. Now this one's interesting. The derivative of x is like x to the first power. So when I do that, I'm going to bring down the 1, and then I have x raised to the 0 power. But x to the 0 is just 1, so this is just 1. This ends up being 1. Right? Then last, we have the derivative of 7,053. Well, remember, 7,053 is just a constant, so its derivative will be 0. So all in all, the derivative of this thing, h prime of x, is going to end up being 10x minus 13. That's my derivative function. Okay? These problems certainly get more complicated, but these problems, these properties are just illustrated to give you the idea that when you have multiple things added together, separate them into pieces. When there's a constant multiplied, set it aside and do the derivative first. If there's just a constant, its derivative will be 0. These 3 rules and the power rule are going to be used all over the place in calculus, so it's important that you get a good strong hold on them. I need to end this video with an important warning. We do not have a product rule or a division rule or like a stuff raised to a power rule. Right? So if somebody asks you, hey, take the derivative of x squared times x cubed plus 1. You can't, we don't have rules for this. We have no idea how to deal with things when they are multiplied together. We would need a product rule for that. Or we'll need to simplify this somehow before we take the derivative. We don't have a division rule. So if somebody asks for x cubed minus x over x squared, you can't just take the derivative of the individual pieces. Nobody said you could do that. We don't have a division rule yet. Right? So understand, we know how to do some things, but we're expanding our knowledge. I'm going to be expanding that more in the next video, so hopefully you've got brain power left, and I'll see you there.